Welcome back, everybody. I hope you enjoyed your snow day. In this short video, we'll discuss the basics of inheritance, which will be pertinent to the Project 4 assignment that you'll have due at the end of this week on Sunday. We'll also be covering some inheritance material that's related to the project during your labs this week, so make sure to attend that as well. In order to begin discussing inheritance, I'm going to write a brief class called Oldie. It just has a few fields and a single method that we can inherit. So here's a public class Oldie. Let's give it a field that's protected, and we'll discuss what protected means in a little bit, but it's akin to private and public. I'll call a string name. In order to make an Oldie, I'll need a constructor, so that has to be called Oldie. Maybe we'll take a string argument s and set this dot name equal to s. And finally, we'll give it one behavior, a method that's void, and we'll call it introduce. And all it will do is print out a brief introduction. Hello, my name is, and print this dot name. That should do it. Okay, I think this all looks alright. Press compile. Dr. Java's compiler says okay. Can I make an Oldie? New Oldie. I need to give this a string argument that's name. How about Homer? Here's O, and I will ask him to introduce himself. Hello, my name is Homer. All is well. Okay, so far so good. Now that should be old hat by now. Definition of a simple class. Here's where things will get interesting. Let's make a class that extends this. So inheritance is achieved in Java by saying here's a new class called a youngin. And the keyword extends that shows up after the class name. And then some other class, a single class that is extending. In this case we will extend Oldie. I can't make a youngin yet because I will need a constructor. For the moment, let's make a single constructor youngin that takes, maybe no parameters. How's that? And save and see how we do here. So we'll call this guy youngin. So that, overwrite the old version. Okay, so there's a nice looking class. Let's see how we do for compilation. Public youngin extends, I probably need a class, don't I? It is indeed a class. Compile, well, that sucks. Found no arguments, something about the Oldie constructor cannot apply to given types. Interesting. Well, at least it's recognizing that youngin and Oldie are connected in some ways. What if I disconnected them? So now we just have a plain class youngin that has a single no arguments constructor. And that looks like it's okay. I can make a youngin. Y equals a new youngin. No arguments constructor. Okay, looks alright. So there must be some funniness that happens after introducing this notion of extension. So they compile and look carefully at this error and see that, yes, there is a connection, that there's something going on with this constructor. This is the first bit of trouble that a lot of you will probably run into. There's a strong requirement in Java to connect children class to their parents. Part of that is in the construction of a child class. Whenever you are constructing a child class in its constructor, it must call a constructor for its parent class. This is done using the super keyword, so super. And if you look carefully here, you'll see that apparently I'm calling constructor for Oldie. It can't be applied to no arguments because it's required that it takes a string instead. So what Java is doing here is implicitly putting a constructor, since I didn't put one explicitly. So code would look sort of like this if I removed it. In fact, if I compile this explicit version right now, I'll get the same compile error. Nothing changes down here. The reason is there is no way to build an oldie with no arguments. All oldies take an argument to the constructor. I'll go back over here. They take a string, which is what the compiler is in its vague way trying to tell me. So you need to give this guy a name. Let's call him Young One for now. So if my calculations are right, we should be able to compile now. I call up my history and make a new youngin and ask youngin, can you please introduce yourself? You might wonder, well, youngins really don't know how to introduce themselves, but in fact, all children know how everything, or know how to do everything that their parents do. And if not told otherwise, will do exactly as their parents do. So here, I've constructed myself, in this case as a youngin, according to how my parent would construct itself, with the name Young One. And then when asked, please youngin, introduce yourself, look around in the youngin class and see, oh, there's no definition for introduce, but don't fret, I will look in my parent class. Or here in oldie, I will be able to introduce myself according to this set of instructions here, which actually references this .name. Interesting. Youngin doesn't have a name, a field associated with it, but inherits all of the protected or public fields from its parent class. And since name is a protected field, all should be well. Okay, so far so good. Well, that's kind of boring. We don't want all youngins to be called Young One. Let's instead write a constructor that takes a few extra arguments. So I'll give myself a string n and maybe an int age. So I will definitely need to continue building my parent class using something. Here I have a nice string that will probably be its name. So I'll super it and say super.n. I'll say this.age equals parameter age. Maybe I'll call him A just for kicks. I don't have a field age right now, so I'll want to make one. Make it a protected int age. And in addition to that, I can actually make some modifications to fields that I inherit. For instance, this.name equals n plus the young. So despite constructing the name in my superclasses, I can also have direct access to this the name field and make modifications to it in the child class constructor. Let me compile this guy. I'll pull up youngin. Now in here I'll need to introduce two parameters. Maybe I'll call the name Bart and give an age like that, 14. And ask youngin, please introduce yourself. Aha. So introductions happened, but this name Bart was appended with the young up here. That field name has been modified in the child class. So direct access to any fields that are declared in the child class, and direct access to any visible names from the parent class. The visibility part of that is interesting. If I bop over to oldie and change this protected modifier to a private instead, private is the most restrictive modifier. It is going to prevent even children class from seeing that field. So a reference to this.name is going to create a compile time error. Name has private access in oldie. So Java's just not going to let us go forward and see that field. This is bad, so that's why the protected keyword sits around as a sort of intermediate between folks outside the class can't see or touch name, but any children class of oldie will be able to mess around with it directly. One thing that you should be very careful about is shadowing names. So if I do something like protected string name, I've actually created now two separate fields for name. One that exists in the space allocated for youngin classes, and every youngin needs the space allocated to its parent class as well. So there'll be a super.name and a this.name, which are separate. The trouble is that oldie has no idea that there is a separate name for each youngin. So in its implementation of introduce, we'll call the oldie name rather than the youngin name. So our modification here of saying blah 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 the young is not going to show up in any introductions. I'll compile this guy, make myself a youngin, and ask him to introduce himself. Notice the lack of Bart the Young over here. The reason is that I initialized the superclass field name with this value n, and only changed the child class youngin name down here. And the name that's used in introductions is the one that belongs to the superclass. The easiest way to avoid all this nonsense is just never to shadow variable names. Never, if a parent class has a variable named name, a field named name, do not name something similarly in any child class, and this will steer you clear of trouble. So this should return us to our original behavior where Bart introduces himself. Now, as in real life, most of the time, children class do not do everything just as their parents do. This is a notion of overriding methods in Java, and it's done simply by saying there's a new version of introduce, public void introduce. This will be the child's way of introducing itself. System.out.println. Hi, I'm name, and eat my shorts. I'll compile this, ask a youngin to make himself and then introduce himself, and at runtime we'll look and ask why. What kind of a thing are you? Well, I'm a youngin. Can you please introduce yourself? Yes, in fact, I have my very own definition of how to do that. It goes something like, hi, here's my name, eat my shorts. The parent class version of introduces never comes into play. Now that's the part where it's interesting. At this point we may have written an oldie and a youngin class separate from each other, because really all they're sharing right now in terms of code is a little bit of supering and constructing and the single field name. This becomes much more interesting if you are able to mix and match child class with behaviors that its parent does. The keyword super can be used to do this. So I can ask the parent class, or at least I remember how to introduce myself as my parent would, and can access that by saying super.introduce in this case, which calls the parent version of my introduce method. In addition to that, I can do a little bit of extra work here, which is to append a little bit of colorful text on. So this is where inheritance actually shines the most, which is to say there's an existing implementation of introduce, and I need to specialize that only a little bit here. So everything that introduce does from the parent class is done, and here's some additional stuff. Compile and run this. Now we have a mix and match of those two things. First line you see comes from the parent, along with a slight modification that we made to the name that's associated with this guy. And in addition, we have a little bit of colorful text that's appended onto it. So this is the kind of thing that you'll need to do in order to complete P4 and the lab material, which is to access certain methods from the parent class. The parent class that we'll be inheriting from the most is PrintWriter. So in the next video we'll discuss the aspects of PrintWriter so you're familiar with it, and there'll be a third video which talks about inheriting and extending PrintWriter to do some semi-interesting activities. One last little bit. Parents and children are related, and that every instance of a child class can be treated as a parent. So I can as easily say oldie O equals a new youngin. Maybe we'll make this a little bit at least different. Lisa. this should indicate to you that, oh, a youngin